The next topic I'll be covering is variables. Variables are similar to the variables in an algebra equation. It gives the computer the ability to perform a complex equation just as a variable does to algebra. The example here, E equal mc squared, is only derived by Einstein because he used algebra variables. Next, I will walk you through an example, a program I wrote through variable.c, which I will try to demonstrate the needs of variables. Once that is done, I'll go through the component that make up a variable and how to give variables a value. To do that, I will cover the topic on data types and variable assignment. I'm now back in Visual Studio. I've pre-written a program called variable.c. Over here, I will only use constant, where I will calculate the area of circle, circumference, and the area of square based on a length of 3 or radius of 3. The value have to be pre-calculated manually and added in. I'll now run the program to demonstrate. The program printed out whatever I have written and nothing more. Next, I will introduce variable. Here I introduce the variable length, area, circumference, and square. This length is assigned by me, and the area is calculated based on this equation. With that, I'm able to do this complex equation in less than a second. Let me demonstrate. With a value of 3, both the answer is the same. However, should I change this length to another value? The computer can do the calculation in less than a second and give us the result. Notice this value have changed, whereas the constant value does not change. You can do any value you want, and the computer could do it almost instantly. That ends my demonstration. Variables. Variables can be declared by first having a data type and followed by the identifier. I will cover data types in the following slide. For this slide, I'll be focusing on the identifier. Here are some examples of a variable declaration. The data type can be an integer, float, or even a character. The identifier, it can be a single letter, multiple letter, small letter or capital letter, digits, even have underscore. Here you can do assignment of 8 to the character, and here a decimal value assigned to this value. A float is essentially the decimal declaration or data type. I'll touch on the identifier and the restriction that it has. I'll first start from item 5. Here only 32 characters, the first 32 character is significant. This is defined by the NC standard, which is conformed by most compiler in the market. Visual Studio have extended that to 247 characters. We will stick to 32 character, which should be sufficient for all our requirement. Next, item 4, there should be no keyword, so you cannot use main or define as the identifier. There should be no symbols in the identifier and also no dash. Also notice that it is case sensitive, which means that a small a is different from a capital A. No space within the identifier, but you can use an underscore. Underscore is a special character that can be used. Now we touch on number 1 and 2 on how we can define the identifier. The first letter must be a letter, a small a to z or capital A to z, or an underscore, but it cannot be a digit. The following that, the rest of the letter, there is no restriction on this digit. You can have letter, underscore, or digits. Here are some examples of a valid identifier. And over here is the invalid identifier. Here, because of the digit 5, cannot begin with digit, and no special symbols like hex. Here, because of the space, and here special symbols again, special symbols, and here cannot begin with a digit. C consists of some basic data types. Data types define how much memory is allocated to a data and also the range of values that it can take. C have some basic data types, and Microsoft have added a bit more onto it. Here is a list from the Microsoft website. These are some basic data types, and here are some of the additional data types that Microsoft have added. Okay, much more. And data types have both unsigned and signed. For unsigned, you only have positive value, whereas unsigned means you have both positive and negative. For example, for the integer, this integer value, a signed integer value, you have negative 2 and positive value, whereas unsigned integers means only from 0 and positive value up. This is an alternative name, means that instead of integer, you can just use the word sign. And here is the amount of memory allocated for a particular data type. Integer takes 4 bytes, and this underscore integer 8 takes 1 byte. Strings is not a primitive data type. It consists of a group of characters. In chapter 5 on array and string, you will study more on string. Okay, I'm back at Visual Studio with this program variable.c again. I will touch on these 4 topics on variables. The first one is that the statement must be after main. I just run this program again to make sure everything is working fine. Here, the last time we end like this. Okay, next. The first statement, what does it mean? If I put a variable in the middle of the program, everything looks fine, except when I milk it, there will be error. Here there will be some strange error coming out, and I don't quite understand. It doesn't really point to the problem itself, so beware of that. So you need to declare the variables not over here. Delete this, and I put it over here. And now if I run, I should be able to run the program. So remember, first statement after the main. Alright. Here you will actually see some probably warning message that you declare things but not using it. Try to remove any variables if you're not using it. Next, I'll touch on number 2. Let's see what happens if I key in some invalid identifier. For example, I put one value. You notice when it's an invalid identifier, the red curly line will appear almost immediately. Secondly, even when the error occurs in the center, the red curly bracket correctly identified where the problem is. Here the error is because it's a digit. You cannot start with a digit, and here you cannot special symbol. And for the third case, here case is a special keyword. You notice it appears in blue, so anything in blue cannot be used as an identifier. Okay, let's remark that out. Okay, that would cover number 2. Alright, so you need to have a valid identifier. Next, I will show redecoration. What does it mean? If I have declared a variable called x, and now I declare it as a character x. Here everything looks fine until similarly when I compile the statement, you notice there is an error, and it shows here that there's a redefinition. Okay, and it points to the error itself. Remove this. Okay, and it would fine. Okay, or you can change this value to something else, say a z. That should be okay as well. Alright, we have completed 1, 2, 3. Next one, just to show that you can assign a value. For example, integer x, you can integer assign it to 67. Okay, and a character, you can even assign it like a single quotation mark for characters, only for characters. Next, a float. You can say value equals to 0.123. That will work. Or you can also declare value 2 equals to 1.23 e to the power of 2. This is the computer way, the C programming way of declaring float variables. This is equivalent to 1.23 multiplied by 10 to power of 10 to the power of 2. Okay, that ends my demo.